Our solar system is home to some truly fascinating planets, each of which have their own unique characteristics and mysteries waiting to be uncovered, with Venus being no exception. Located just on the edge of the habitable zone, with a radius that is 5% smaller than Earth and a mass approximately 20% less, it is a rocky world primarily composed of silicate rock and metal just like Earth. Seemingly on the surface then, Venus is similar to Earth, and you would have thought it had everything going for it. After all, our closest celestial neighbour shares a name with the Roman goddess for love and beauty. So why is it sometimes referred to as Earth's evil twin, and why has it been so difficult for us to reveal its mysteries? Due to its thick atmosphere that reflects about 70% of the sunlight it receives, Venus is one of the brightest objects in the early morning or early evening sky. It was a little over 100 years ago that all we could really do was to gaze up to this bright wandering star with our telescopes and speculate about what the planet was like and if it held any potential for life. One Nobel Prize winner in the 1800s went as far as hypothesizing that the clouds they could see must be composed of water. Following through on this, it seemed reasonable for them to assume that the surface was swamp-like, and that since it was close to the sun's heating effects, this swampy, damp environment would not be too dissimilar to the tropical rainforests found here on Earth. A quaint theory in today's world for sure, but one born out of looking at a planet from a distance and seeing nothing but a featureless object that is shrouded in a thick atmospheric blanket. This style of observation and understanding remained the case until our technological capabilities allowed us to get detailed data about the planet. It was at this point when the mysteries of Venus started to reveal themselves to us, and we began to get our first glimpse as to the true hellish nature of Venus. Despite being similar to Earth in its early history, Venus underwent a vastly different evolutionary path than Earth over the longer term, resulting in the current extreme conditions we see on the planet today. Whilst it may be on the edge of the habitable zone, the internal makeup of the planet would set it on a very different evolutionary path to Earth. For example, the planet has over 1,600 volcanoes, more than any other planet in the solar system. Additionally, these volcanoes are larger and more massive than those on Earth, with some reaching heights of over 5 miles, creating a significant amount of volcanic activity. This activity would have certainly released vast amounts of sulfur dioxide into the atmosphere through volcanic eruptions. Being that much closer to the Sun, Venus gets 2 times as much solar radiation than Earth, with ultraviolet radiation helping to break the sulfur dioxide into sulfur trioxide. This in turn will combine with the water vapour present in the atmosphere to form sulfuric acid. Venus today quite literally has clouds of sulfuric acid, and these clouds are a defining characteristics of the planet's appearance, as they are responsible for its bright reflective appearance in the sky we see. In addition, these clouds are so thick that they hide the surface of Venus, making it difficult for us to easily penetrate through to the surface and reveal its mysteries. Fortunately though, our technological advancements have allowed us to see through the clouds, and coupled with various space agency visits, we are now building up an accurate picture of Venus. We now know that Venus's atmosphere is incredibly thick and dense, with a surface pressure 90 times that of Earth. It is mostly composed of 96% carbon dioxide, with 3.5% nitrogen and trace amounts of other gases such as sulfur dioxide, argon, water vapour and carbon monoxide. Over billions of years, the atmosphere has evolved to this point, becoming thicker and denser, and in the process trapping an ever-increasing amount of solar radiation, which in turn has caused the planet to heat up. The water that once had covered the surface of Venus is now long gone, having evaporated by the extreme heat. These vaporized water molecules would have been broken apart by the ultraviolet radiation from the Sun, with some of the hydrogen atoms escaping into space, whilst others combine to form the highly reflective sulfuric acid clouds. The oxygen would have combined with other elements in the atmosphere to form carbon dioxide, which has heated the planet further, creating a runaway greenhouse effect in the process. As a result of this evolution, Venus today, whilst having similarities with Earth that make it its twin to our home planet, is in fact a hellish environment where surface temperatures can reach an astonishing 462 degrees Celsius, giving it the crown of the hottest planet in the solar system, despite not being the closest to the Sun, and with it the unfortunate label of Earth's evil twin. In September 2020, a team of scientists announced the detection of phosphine gas in the atmosphere of Venus. This is typically associated with biological activity, as it can be produced by certain types of bacteria and other microorganisms. The discovery of phosphine on Venus raises the possibility that microbial life could be present in the planet's clouds. If this is later proved to be the case through further exploration and missions to Venus, then I'm sure the label of Earth's evil twin will be dropped for something more suitable. Harbinger of life, maybe?